Welcome to this demo on Tosca Data Integrity. Tosca Data Integrity tests end-to-end across all data warehouse landscapes. More and more companies are planning or are already in progress of migrating their on-premise solutions to cloud-based solutions, which offer a higher performance at lower costs. Today we have a great example looking at Snowflake in a data warehouse and some of their features like time travel. Tosca Data Integrity has a layered approach to testing. We set up these different types of tests throughout your warehouse at different stages, ensuring to identify issues when they occur. Using this approach, we are able to test all different layers throughout your warehouse. Testing for data ingestion, storage, ETL transformations, marts and methods, reporting and analytics. Another use case is replication of data when you're upgrading databases. More commonly, what we're seeing is customers moving from on-premise to cloud-based solutions. Tosca Data Integrity covers this too. Companies we speak to are migrating off on-premise warehouses and moving to cloud-based solutions, such as Snowflake. Here we can see some of the highlights that Snowflake has to offer. And Tosca Data Integrity works with all Snowflake instances and leverages these features in testing. In today's example, we are using publicly available healthcare data. I've moved and transformed this data in my warehouse in order to show how we can check received flat files for metadata and formatting accuracy before any moves, check data moved to SQL Server warehouse for completeness, correctness, and integrity against the flat file, migrating data from SQL Server to Snowflake by doing reconciliations including transformations and Snowflake's time travel feature, and check that Power BI reports reflect accurate data from Snowflake's marts. So let's have a look and see how we can create, maintain, and execute all these different types of tests in Tosca Data Integrity. Before we jump in, let's have a quick preview of my environment and data that I'll be using to set up our tests with Tosca DI. We'll start off with my flat files. These are the flat files which are publicly available from Medicare. They're all in CSV format, but I've also downloaded some FHIR files, which are the Healthcare Data Exchange Standards, in order to show you how we can use semi-structured files like JSON or XML, for example. After we've done our testing on the flat files, we will move to our data warehouse, where we start off in SQL Server. All my data has been uploaded here. And then we'll move over to Snowflake, where we'll migrate our data from SQL Server to my Snowflake data warehouse, and then jump in and look at our time travel features that we have here as well. We're also going to look at some Power BI reports along the way, where I'm going to compare the data in the Power BI reports to the data in my Snowflake marts. So this is what I've simulated for today's demo, and we'll start off by jumping into Tosca DI, and you can see this is Tricentis Tosca. We focus on model-based automation across all technologies and applications for UI and API, and our data warehouse and our data integrity is basically an add-on to Tosca's model-based automation. So this allows you to do the same model-based automation across your data warehouses, reducing your scripting and maintenance effort. So I'll give you a quick preview of what we mean by model-based automation in case you're new to that. So if I open this up, you'll see here, this is what we refer to as models. We create models for different technologies to pull data or enter data or verify data from them. And this model is what we use to automate different types of tests. It's the foundation of our automation. It gives us a single point of maintenance and allows us to scale automation across enterprise companies. If I click on the first one, you can see here's an example of a model that represents a web application with different controls and drop downs, and we can enter and pull data from this application. You can see the same for SAP, .NET, different Java-based applications, whatever it might be, APIs, UIs, terminal emulators, we can automate it and enter and pull data from it. The data integrity add-on allows you to pull data from large data sources. As I mentioned, when we saw JSON files, we can load this up into a caching database, normalize the data, and then compare it to other data sources. Here's a pre-built model that allows you to connect to any source and compare it against any target. We have different out-of-the-box connectors that allow us to connect to different databases or files, whether they're on-premise or cloud-based, and you can compare and apply different row options, column options, different sort of formattings to take care of a lot of transformations out of the box. And this really reduces the SQL queries you have to write. So we're going to have a look at more of this in detail later, but these models are leveraged in what we call test cases or templates. If we have a look at some templates, what we can see is when you install Tosca DI, you'll have a number of predefined templates out of the box, whether we're pointing at files in large databases. We call this pre-screening and vital checks on different levels, different types of tests, and also on field level tests. That's the ones we're looking at here. But just to give you an example, let's say we wanted to do a total row by row count from a source to a target. Here's a pre-written template. If I expand this, what you can see here is we'll establish a connection. I'll show you that in a second. But here's the query that we'll run. It's a predefined query and it's all parameterized. We're going to launch a wizard in a little while. It's going to point to a file, point to a database, on-prem or cloud, and it'll pull the information it needs from these data sources, inject it into these SQL queries that are parameterized, and compare the resource count from a table, for example, to another table on a target. So here we're doing a buffer function, which means save the value to a variable name called source count and compare that source count against the target, doing a verification. So there's a large number of these predefined templates provided when you install Tosca DI. You can use them and you can also create your own. So if I copy this, for example, I have a new one down here and I can say demo SQL. And now what you'll see is if I expand this, I can customize this query, doing a very basic customization where date equals, and I can use some dynamic expressions like date to filter by further querying. And then it'll run that based on the state and compare it to the target. But these are the SQL queries in these templates that are going to be leveraged in the wizard later. And this is more on the metadata and formatting side. And later we'll look at the actual data itself. So if I collapse these, those are the tests or templates leveraging models. And we also have test sheets, which are created when you point to the actual data source and the target, which you'll see a bit later. So it's creating data-driven testing using wizards, but we're doing this by pointing to your sources and targets, wherever your data is, and these tests are generated at a large scale. So how does that work? If I click on my sandbox folder over here, you can see my data integrity tab, and you can see I can point to a file to a database on what we call vital checks, which is more on table level, and then we can point to them on field level. And then later we'll look at the data itself. But it's all these first 5 tests are driven by wizards, which are very easy to create and maintain on a large scale, and allow you to focus more on transformations. If I close this down here, what you'll see is we'll start off by setting up a layout for your environment. So you can see I'm starting off with some flat files, going to SQL Server, doing a migration in today's example to Snowflake, and then comparing against Power BI. So we can build a structure based on your environment. If I copy this, just to save me creating the structure myself, you can see this is my landscape I've made up for today, and my different types of tests I want to do at different points along the way. I'll copy that, go to Tosca, and just paste that that structure over here. And now I can go through using my wizard to create the first set of tests, using the wizard over there, and then I can focus more on my reconciliations and transformations down here and my reporting and profiling. So let's do some examples. And if I start off by pointing to a file, and we'll point to the CSV that I mentioned we pulled from Medicare. So let's navigate to my files. And here I'm going to point to complications and deaths by hospitals. Load up the CSV. We can push the first column to the header. We can say whether we want fixed lengths or we want to choose our delimiter, and we'll get a nice preview of the file. Then based on your business rules that you're actually testing against, I can hit the next button now and say what type of tests do I want to run for this file. And you can see it gives me a preview here, so I can say, for example, I want to make sure the facility ID has no empty values. I want to make sure it's numeric. I want to make sure the minimum value is, let's say 0, 1, 0, 0, 1. And I can say the maximum values, for example, and I'll make something up here, 5. Okay. So we're basically using these tick boxes, and these are referencing those templates I showed you before. So they're out of the box, or you can create and customize them yourself. But for now, let's stick with that. Let's say that also has no empty, and I'll just create a few. Let's say you get to state and you want to customize your own. I can say it has no empty values, and I want to say it has a value range. So we want to make sure that this field has the correct states. Anything outside of the actual 50 states should throw back an error. So I've got them all copied here. Let's copy my states, go back here, and paste them in here. And now you can see it's going to do a value range check against the values that I've pasted in here. So you can set up a lot of these on the fly within the actual wizard, or you can customize the templates as well, like I mentioned and showed before. So I'll do a few more, so we have a few more tests created at the end. Let's say there's a denominator, and this is a unique one. There's a score, and there's a row count. You might know what that total is. Let's make up a number here again. All of this will be created for you. I'll hit the next button. That's my predefined template. And what we can also do is create an execution list to hook up to any build tools or schedulers to run these periodically or when it makes sense. And we can tie it back to a business requirement, whether you enter these yourself or whether you pull them in from another tool like Jira or Azure DevOps. You can prioritize them and do risk-based testing. So here we'll report on number of tests that pass and fail, and here we'll report on the business risk being covered. I'll hit the finish button, and now based on the pre-built models, the pre-built templates, or the ones you've customized, it's going to go through, pull the information it needs, and create these tests. This is a very simple example, just using a basic flat file in CSV format, but we can do these on a large scale where we can potentially also generate tests by the thousands when we're doing them, for example, on database level for vital checks, and doing metadata or format or nullness, or checking that the foreign keys on the source match the target. All of these tests are normally skipped over in data warehouse testing because they're extremely time consuming. But here we can set them up from day one and identify issues as they happen and pinpoint where the data goes wrong. So you can see here's my tests that have been created. If I select my value range one, this is my execution list. I can jump to the actual test that was generated. There's the template. And if I expand the actual test that will run at runtime, it's going to point to my file, point to the column state, and check the value range matches these ranges that I set up through the wizard. Okay. What it also does at the same time is it creates a data sheet. So this is basically creating data-driven tests using the source and target or single source like now, parameterizing it all using the date, the file names, tables, columns, the types of tests, and these can be updated later if you want to, or you can go through the wizard again, and then we can click on that and simply do an update, which we call reinstantiate. So to quickly show you that, let's just add another value to our range here, and we'll call ZZZ, so we can see it very clearly. Come over here, do an update, click into here, and then you can see I've added my ZZZ to the value range. So all your maintenance is done in the test sheets or the templates, and Tosca will generate these tests on a large scale for you using data-driven testing. I mentioned our risk-based testing. All your requirements and tests can be prioritized using frequency and damage, and this will give you a more meaningful risk-based report. I'll show you some examples of that when it's completed later. So I'm going to jump ahead and show some field level tests. All of them are basically the same going through wizards, but let's have a look at some field level tests on database to database level. And I mentioned before my data has been uploaded to SQL Server and I migrated to Snowflake. So one of the tests you might want to do is do some field level tests to make sure that the data integrity has been kept. And I'll start off by pointing to my SQL Server database. You can set up different connections using the ODBC connections like ODBC drivers. You can extract DDLs and connect to them that way if the environment's not available and then run them later. But it does the same thing. It parses the schema and pulls the information back. I have 11 tables here. There's a couple I'm going to focus on, which is the hospital and state in today. But you can add filters by schemas and by table names as well when you're dealing with thousands of tables. I'll hit the next button, and now we're going to connect to my Snowflake instance. And what you can see now, it came back and said there's 130 tables up there. I'm not at all interested in all of them. There were some that when I first got my instance, they were already there, but you can see there's some that I actually uploaded. So I can actually filter by, for example, public, and just bring back all the tables that I actually uploaded myself. I'll hit the next button, and now we basically need to match the tables from source to target, as some renaming might have happened as part of the upload or the migration. It'll auto match where it can. If it hasn't found a match, you can manually map them by doing a simple drag and drop, and then mapping even the fields on the field level. But you can also create mapping files. You can manually map them here, then create a mapping file using the export, or you can load one in. I already have one set up, so I'm going to jump over here to my mapping files, and you can see table matching SQL to Snowflake. I'm going to load this up. Those are the two tables I'm interested in. You can see on the source I had 16, on the target I had 18, so 2 were added, for example, but you can drill down and actually see what tables were lost or added along the way. Okay. I'm going to hit the next button, and now I'll see my 2 tables and all the columns from the tables. So now I simply go through and say I want to do a minimum length test from the source and make sure it matches the target. Maximum length, whatever it might be, average length, min value, and these are all those templates. If I scroll to the end, you'll see there's the one I copied and pasted earlier when we saw the templates, and I customize it with the date function. So that can also be selected. So you can create and customize your own. You can delete the ones that are not relevant and select them using these tick boxes, just like I did with the file. What I'm going to do now is just go Control A, select all of them, which isn't correct, but just to show you, we can generate these tests on a large scale if we need to. Select my tick boxes for creating execution lists and risk-based testing with requirements, and now the same thing happens. Now it goes through and creates all the actual tests for us. Here you can see I've got 442, and once we have a large number of tests, Tosca DI will actually use parallel execution to reduce the runtime. This is all built in. We have parallel execution to run SQL queries in parallel, depending on the machine or server that's running the executions. And we also have multi-threaded execution in memory caching. So when you look at the data, it actually caches some of the data at runtime. None of that's stored within Tosca. It's in memory caching, it grabs the data it needs at runtime, compares it, and then drops it again. So let's have a quick look at what was created again. If I find my demo SQL for one of the tests, I'll jump to the actual test like I did before, do my expand, and what you'll see here is it's connected to my source, which is Medicare SQL database. Run my query. You can see it's removed the parameters and pulled the actual schema and tables in and the fields. There's my query that I amended and comparing it against the target, just like we saw before. It's also got the data sheets which have been created for source to target, which can be created and maintained here. And again, we have our requirements and our execution section. So that's all on the metadata and formatting side. Once we've set up these tests, and again, this is very useful for pinpointing errors along the way, so we don't have to write long SQL queries at the end when something goes wrong to try to debug and work our way back. We can then move to our reconciliation. Now what we have here is an out-of-the-box model, which I showed you before, which allowed you to point to a source and a target and create these tests for us. What I'm going to do is not to save time today. I'm not going to set them up manually. I'm just going to go to my pre-created tests for reconciliation, profiling, reporting, which covers transformations as well. And here's my completed one. And we can have a look at how we can compare data using these pre-built models. So I've set up all these tests already, and what we're going to do is have a look at some examples. So one of the things we can do is compare data from the SQL Server database to Snowflake, and this is the migration use case we were talking about. So for example, I can connect to a table using my pre-built model here. I can go to my drop-down list, just like you saw in the wizard. All those connections are saved, and you can set up as many as you need to, and I can connect to my SQL Server database, run my query, and connect to my target, which is Snowflake. Along the way, you can set up settings like, is the first column, the first row contains the column names. I can say true. I can remap column names if they've changed completely, like you saw me do in the wizard for those types of tests. Here we would just remap them ourselves, and this avoids you having to write a lot of SQL queries. You can trim out double quotes in the headers. When I uploaded that data, a lot of double quotes appeared in Snowflake, so it had a mismatch, which would create a lot of errors, but you can see all the sort of transformations or formatting changes can be taken care of using out-of-the-box functions here, like substringing, uppercase, lowercase, removing commas and dots. And of course, you can write your old SQL queries as well. Then I'm going to point to my target, which is my Snowflake database. I can run my queries there, apply similar options if I need to, and my row key in this case, I'm just using all my source row columns as my row key. And you can type them in yourself. You can use comma semicolon to separate them, and then you can write some reporting. So what we're going to see is all of our reporting is stored in the execution list, like I mentioned, but when you're looking at terabytes of data, millions of records, this gets very tricky to read in our execution lists. Those report on a high level, but if you want to see the data and pinpoint source and target fields, that's where we can show you that. And we can create these out-of-the-box HTML reports, so you can save them to a shared folder somewhere that everyone can access. And you can do things like even add tolerances to different field levels or columns where you need to add plus or minus, and then verify that they have a match. Other things we can do, like we mentioned before, is we can also leverage functionality from Snowflake, such as the time traveling feature. So what we'll do is we'll jump over here quickly to Snowflake so you can see what we're talking about. Here's the data I've loaded up. What we're going to do is we're going to compare my data from my SQL Server, and you can see when I run this query, there is 91,394 rows. When I moved it to Snowflake, I only had 8,600, and this was come as the formatting. Some of the formatting changed. So when I uploaded, there were some errors along the way, but this is great to see when you run the comparison what the reports look like. So I left that in. We'll have a look at that, but what we'll also see is, if I jump over here, the time travel function. So what this means is if you run these queries, it basically says I can use a current state and say, what does my data look like right now, and run my query. And I can also go back up to 90 days and say, what did the data look like in the past? This is Snowflake's time travel function. So what you can see here is at the moment, the response is all saying not available. So what I'm going to do is update the response to say yes. And if I run my query now, it's going to tell me the response is saying yes. So the functionality Snowflake has for time traveling means you can go up to 90 days. So what I've said is go back 5 minutes and tell me what the data looks like. And there's my little format for the at and the offset going back 5 minutes. And if I run that query, it's going to say 5 minutes ago it was not available. So basically this is like comparing a source to a target, but we're using the current state to the time travel state. So this is something we can also set up using our pre-built model. If I jump over here, what you'll see is using the source, this is our present state, and my query here, there's my current state query. I'm going to compare it against the target, which is just 5 minutes ago. And the other options are quite similar, but I'm also going to generate that report over here using different, and you can obviously rename it the way you want, have different settings like max out after 200 if there's too many errors. In my case, that will be the case because I've intentionally set this up, but you can see all the different examples there. I'm going to run these in a second, but I'll just go through the rest. Other things you can do, for example, is I mentioned before we had the healthcare data exchange standards. So what happens when the file is not in a text or CSV format and it's semi-structured? What we can do is we can load up the actual JSON file or XML file. And here's my example here. And you can see here's my JSON file in the different format. What it'll do is it'll load this up into a temporary database, a caching database, and it'll normalize it and create different tables for the different levels within the file. And then what you can do is once it's loaded up to my caching database, I can simply point to my caching database, join up the tables that it will create based on that structure of the XML or JSON file using inner joins. Apply the same column options, like for example here I had to rename certain columns from source to target because the XML file had different naming conventions. When I normalized it in my caching database, it changed. And compare it against the target over here. Okay. So whatever the file structure is, we have out-of-the-box models or database it is. We have out-of-the-box models that point to it and allow you to do this compare from source to target. And we can work with tables and data in different formats. We can create custom modules to normalize that data so that these modules can then be leveraged. So I'll jump over here to my execution list. Let's do a quick checkout of my data. And what you're seeing is all my execution lists for all my data, for all my test cases that I've created, and I've combined them to an end-to-end flow to meet the process of my data warehouse testing. And you can see I've got different tests for different pre-screening, vital checks, reconciliation along the way, and some reporting and profiling as well. So what we'll have a look at here is if I open up some of these, for example, compare SQL Server to Snowflake, go to that log file that was run. Let's look at the results here. It did the compare, it failed. Now, if we have a look at the results here, you can see there's all the data. That's very hard to read. So what we've got is the out-of-the-box reports. If I jump over here, and when you run these reports, if I click on SQL Server to Snowflake, this is the report that's generated when you run that test. There's my 9,000 rows from SQL Server. I uploaded it to Snowflake. It found 100 errors, and that's because I actually told the report to error out after 100 instances. And I can go through and see what actually went wrong. So in this case, there was no differences. We'll see an example of that in a sec. But what actually happened is when I uploaded it, I lost a lot of the data. So I can go to all, it'll load up all the data. And it's basically saying, as we saw in the summary, is a lot of the data that was in the source was not matched in the target. So all this data was found in the source, but not in the target. And we have different levels of errors that you can drill down to. Okay, so that's an example of the data not being carried across. We can have a look at, for example, time travel feature as well. If I double click this one, what you'll see is there was a successful comparison. And this is before I actually did the time travel function. Now that I've done it, if I run it, it will error out and say there's a mismatch. So I can jump over here. Let's see us run one of these. Let's run my time travel test. Just so you can see it's actually going to start its own little BI execution engine. And this is different to the standard Tosca one. It's a lot faster. Like I said, it's in-memory caching. And if I jump over here, you can see now it failed. Come over here. There's my latest report. It's failed. And you can see there's some failures here based on my differences. I can load it up. I can say how many do I want to see. I want to see all of them, for example. Scroll down, move across, and you can see the data changed from source to target. So it'll pinpoint exactly when something goes wrong. Here I use the time travel function, but again, whatever the data is from source to target, whether you're doing straightforward ETL testing, whether you're doing migrations or time travel like we have here, it'll give you this nice, easy to read HTML report, okay, and pinpoint where the actual errors happened. If I go back to Tosca, you can obviously see here we have this level, so you can run reports based on this, and you can see my other reports here. And here's some execution lists for my reporting and profiling. We'll have a quick look at that. If I come over here, let's look at my tests for reporting. And in my report, we're actually going to launch Power BI. If I expand this, you can see I'm going to launch my URL, navigate to my actual report, and pull some data from the screen. Okay. So the way we did this is we create models for our reports, whether it's Tableau, Power BI, Cognos, and we drag and drop them. We create our test, run our filters, and this will pull data from the actual report, run some queries against my Mart and Snowflake, for example, and then do a simple compare and compare the two values together. And in this case, it's the footnote one I'm pulling from the Power BI report and comparing it from a value from the database that I pulled from the Mart over here. So let's run this part of the test, and I'm just going to launch my actual Power BI report. And it's going to navigate to my actual report. So any filters or navigation you have to do along the way, we can take care of that within the automation and then pull the data from the actual report. As you can see here, run the query against the Mart and compare them together. And this is all using model-based automation. If there's an API available, like in Tableau and Power BI, if they're web-based, there's generally like an API behind it. We can pull the data from the API, save it as a XML or a CSV, and then use that to compare the data against the actual mart or anywhere along the warehouse. A lot faster and a lot easier to create and maintain. But as you can see, we can pull it from the actual report itself, the interface. So that was just an example of how you see we can set up different tests with different file types, doing migrations, very basic. We've done this with a lot of customers with obviously a lot more far complex environments, and done a lot more different types of tests, customized these actual templates to meet their requirements along the way. But hopefully that gave you a good idea of how Tosca DI can work with migrations like we saw today. Thanks for watching.